Storing forage crops as silage for year-round feeding is the basis of animal agriculture in North America. More and more, bunker silos are being used to store high-moisture corn, corn silage, and haylage. Bunker silos can be made of different materials and come in many sizes. Some are formed by concrete walls. Others are earthen or wooden-walled. But common to all bunker silos is the need for good silo management. For example, dry matter losses in bunker silos are typically 10 to 30% and can be even higher. This is like losing 1 acre of forage out of every 5. With good management, these losses can be reduced and money saved. For every dollar invested in better silo management, about $3 are returned due to better preserved silage and improved animal performance. Bunker silos require more attention to the ensiling process than other silo systems. Yet over time, they cost less and can be more effective as a storage system. In tower and bagging systems, packing is determined by their design. In bunker silos, handling and packing procedures must be managed to ensure a high-density silage with minimal exposure to oxygen. There are 4 parts to bunker silo management: harvesting, filling, feeding out, and monitoring. To get the most out of a bunker as a storage facility, it's important to understand the ensiling process. Simply put, ensiling is the process that preserves and stores forage. In a bunker silo, proper ensiling limits the silage exposure to oxygen. Management practices directly affect oxygen levels and how quickly oxygen is eliminated from the silage. In the absence of oxygen, the silage can undergo a good fermentation. This helps to stabilize and preserve the nutritional content of the forage. By harvesting at the proper moisture content and encouraging or supplying beneficial lactic acid-producing bacteria, conditions for good fermentation can be enhanced. Finally, by properly sealing the silo and controlling exposure to oxygen at feed-out, the amount of oxygen getting back into the stack and causing nutritional loss may be controlled. When forage is first put in the silo, oxygen trapped in the air spaces of the silage is consumed by plant respiration, molds, yeast, and aerobic bacteria. This creates anaerobic conditions for fermentation. If anaerobic conditions are not established, microbial activity continues to cause decay in silage quality. As oxygen is consumed, dry matter losses occur as sugars are used up by plant cells, bacteria, molds, and yeast. The loss of plant sugars reduces forage quality because sugars are high in energy. A byproduct of this aerobic process is heat. This can denature plant proteins, creating bound protein, so less protein is available at feeding. Finally, molds produce spores. These spores will begin to grow and further degrade the silage anytime oxygen re-enters the silo. Once the available oxygen has been consumed, fermentation follows with rapid growth of the lactic acid bacteria. These beneficial bacteria convert plant sugars to lactic and acetic acids. The buildup of these acids reduces pH of the silage. When the pH falls between 4 and 5, the bacteria die and fermentation stops. The silage enters a stable period. Proper moisture content is critical to encouraging a good fermentation. If forage moisture is too high, there's a greater chance that Clostridia may take over and dominate the fermentation in the silo. Clostridia are harmful bacteria that break down protein and produce ammonia. This raises pH and creates products that have a putrid smell, affecting animal intake. Too much moisture can also cause an environmentally harmful seepage that must be contained. If the moisture content is too low, the silage is prone to become moldy. When the moisture content is correct, lactic acid bacteria can dominate, and the silage is well preserved. Fermentation rate is also important. When fermentation is rapid, the pH falls more quickly. This helps preserve the quality of the silage. To ensure a rapid fermentation, a research-proven inoculant that contains lactic acid bacteria may be used. Silage stays stable as long as oxygen is limited. Stability will depend on how well the ensiling process is managed. So there are 3 goals in ensiling. Get oxygen out fast, promote a good fermentation, and keep oxygen out. Good management makes all of these happen. Bunker silo management actually begins during harvest. 2 things to remember besides harvesting at the optimum maturity are harvest at the best moisture content and chop at the best chop length. Forage should be chopped fine enough to allow good compaction in the silo. That helps limit oxygen. Also, finer chop length allows for lactic acid bacteria to acquire and use sugars more effectively, which results in faster fermentation. But chopping has to leave enough long pieces to ensure proper rumination. Rations with too much finely chopped forage can cause lower milk fat, lower intake, and diminished animal performance.
What we start out with is we like to chop very quickly, like we're into corn now. It's just nicely getting to the moisture levels that we want. So when it's right to chop, we run day and night. And we have 2 trucks. We have truck capacity enough to keep ahead of the chopper at all times. The length of cut, we're working our way back to a longer length of cut. We had been all the way to 3/4 of an inch a few years back. Worked our way down to 3/8. Now we're considering 3/8 might be just a bit short. And what happens is if you keep the knives and the shear bar up where it should be, 1/2 inch is probably as good, or 5/8 as good as somebody that's chopping 1/4 inch that doesn't sharpen their knives and has a worn out shear bar. So we try to keep knives up real sharp, and the shear bar is real close. And so now we're gradually working our length of cut back to a little bit longer.
Usually a 3/8 inch setting on the chopper is about right, but there are many other factors which affect particle size. These include crop moisture level, ground speed, initial length of the chop, and the number and sharpness of knives. It's important to check particle size during harvest. Chop length can be measured by using a set of 1/4 inch and 1/2 inch screens. Sifting the forage separates it into long, medium, and short pieces. About 20% of the pieces should be longer than 1 1/2 inches. For haylage, about 50% of the forage should pass through the 1/4 inch screen. Of the retained particles, 50% should pass through the 1/2 inch screen, leaving about 25% of the total sample on top. This separates hay crop into 3 piles, shorter than 3/4 of an inch, 3/4 to 1 1/2 inches, and longer than 1 1/2 inches. For corn silage, 25% should stay on top of the 1/2 inch screen. If many cob slices are thicker than 1/2 inch, chop finer to break up cob slices, or consider a kernel processor. The cob represents 10% of the total fiber in corn silage. If cows are not eating cobs, rations must be adjusted. As mentioned previously, crop moisture content is very important. It not only regulates fermentation in the silo, it signals a crop's readiness to harvest. For corn silage and grass haylage, the moisture content should be 65 to 70%. For alfalfa haylage, 60 to 65%. This promotes the right fermentation in the silo and avoids seepage. Monitor moisture content closely during harvest. This Koster tester drives the moisture from the forage. By comparing the wet forage weight to the dried forage weight, Moisture content percentage can be determined. A microwave oven and scale can also be used. Harvesting is the first place to exercise good management practices. Filling the bunker is the next. The objectives here are fill rapidly, pack tightly, cover completely and quickly. Rapid filling reduces the time the silage is exposed to oxygen. This means that the time between the start of chopping and closing the silo should be kept to a minimum. Total filling should take less than 10 days, including no more than 3 days delay. To shorten the filling period, make sure the harvesting equipment and labor are matched to the size of the silo being filled. If the silo is too large, filling will take longer. For example, if a silo holds 1,000 tons of silage, you need to average 100 tons of forage harvesting per day. Never use a blower to fill a bunker silo. It introduces too much oxygen into the stack. There are 3 methods that have been commonly used to pack bunker silos. Height before length, where the silage is filled in vertical sections. This makes it difficult to pack. Length before height, where silage is added in flat sections. This exposes more of the silage to air. And the progressive wedge, which has been found to preserve higher energy values than silos filled the other ways. The progressive wedge filling method reduces the silage exposure to oxygen and provides for better compaction. It's an efficient packing method which allows the silo to be packed quickly.
We looked at several bunkers through the years, and we found that it appeared to be a lot more spoilage on the silos, or the bunker silos, that didn't have walls. There was more surface area exposed, harder to pack on a slope, steep slope especially. And so our emphasis was to take and put walls up. Higher was better, so we went to 16-foot walls. And the problem that we run into is when we go above the wall, we get the steep slope, we can't compact it, and we have a lot of spoilage on the steeper slopes. So we're trying to get away from that by going higher.
As a guideline, spend 4 to 5 minutes packing for every ton of forage placed in the silo. A 7-ton load should be packed for almost 30 minutes, assuming one 13,000-pound tractor is doing the packing. Pack in the progressive wedge pattern. Pack the silage tightly and continuously between loads, and use a wheeled tractor rather than a crawler. A wheeled tractor concentrates weight through the tires, unlike the crawler, which spreads its weight along the tread.
The tractor that we pack with at this time is pretty well matched with the chopper that we have. We have a man and a tractor packing on the bunk 100% of the time, and his instructions are to keep moving at all times at a slow, reasonable pace, so when the next truck comes in, the pile's all spread out and all packed.
If loads are coming in too fast to allow for adequate packing, use a heavier tractor or use more than one tractor at a time. Very heavy tractors improve packing when filling rates are very fast. Don't try to pack more than 6 inches of forage at any one time. Better compaction will result when packing thin layers of forage. Don't let loads pile up and then try to pack them all at once. Also, packing at the end of the day after filling has little benefit. An indication of packing effectiveness can be seen in the layers or strata of silage. Tightness of these layers shows good packing. Safety of the tractor operator in packing is important. If the silage is packed so a crown develops, the tractor is in danger of tipping over. If more storage is needed, it's better to add bunker space and avoid large crowning. Make sure the packing tractor is equipped with rollover protection and seat belts. Covering the silo is a must. Use a good grade of agricultural 6mm plastic. This reduces tearing and helps the plastic stand up to the weather. Black plastic is okay in cooler regions, but white may be best in areas where extended periods of 90 degrees or higher occur. If the plastic is not anchored and moves up and down in the wind, it will force oxygen into the stack. Once again, when oxygen enters the stack, it sets off the growth of molds and yeast, causing heating and loss of nutrients. To hold the plastic down, tires should be placed side by side, tire to tire. This uses about 25 tires per 100 square feet and results in ideal coverage. As a minimum, 15 tires per 100 square feet has been associated with lower silage temperatures, less dry matter losses, and higher levels of available protein. Covering the bunker with plastic and tires may not be a pleasant job, but it can be made less messy by wearing throwaway coveralls. If the silo is covered properly, the improved preservation of feed quality translates to about an $8 return for every dollar spent for bunk coverage.
Covering in tires, it's a nasty job. Anytime we see bubbling of the bunker after we've covered it, when the wind blows, you know you have a problem. If we go through the investment of buying the plastic, the labor to put it on, remove it, take tires off, it's costly. So the goal is no spoilage under the plastic.
After harvesting and filling, feeding out is the next important step in bunker silo management. When the silo is open, the silage is exposed to oxygen. With the reintroduction of oxygen, harmful microorganisms can grow. Therefore, the objective in feeding out is to minimize the silage exposure to oxygen. When removing silage from the feed-out face, keep the face as undisturbed and as smooth as possible. Lifting up on the stack shoots air deep into the silage mass. Instead, scrape downward with the bucket or along the side. This prevents leaving an irregular face or overhang, which can be dangerous and reduces bunk life. Some equipment is designed to preserve a smooth working face. This cutter blade attachment is an example. It cuts a section of silage from the bunker while compressing the cut face, helping to keep out air. When feeding out, remove some of the tires and only peel back the plastic from as much silage as will be used in a day or two. When working near the edge, take care that the silage does not collapse.
Feed out, we like to feed about 6 inches off the face and work across the face. And work across one way, come all the way back, and work back across on all the bunkers. We like a vertical face, keep the face of the bunkers we're feeding as straight up as possible. Clean up the loose silage along all of the face at all times, and it's a worthwhile process for us to spend the time to try to keep the person motivated to make sure those practices are kept up.
Feeding out quickly is important, especially in the summer. With slow feed out, the silage is given too much opportunity to spoil in air. With fast feed out, only fresh silage is fed to the animals. At least 5 inches per day should be removed from the face. To achieve this, the size of the working face has to be matched to the dry matter needs of the herd. The width and height are extremely important in sizing bunker silos correctly for proper feed out. As an example, if we use an average density for corn silage of 18 pounds dry matter per cubic foot, a 10-foot-high bunker, 30 feet wide, would have to use up 2,250 pounds of corn silage dry matter per day. A 50-foot-wide silo, the same height, requires 3,750 pounds of corn silage dry matter be used for feed-out to remove 5 inches from the bunker face. Good management should be followed throughout harvesting, filling, and feeding out. But how do you tell whether these management practices are working? Test the forage frequently. The test sample should be typical of the silage fed to the animals. By removing the sample from the mixer wagon, a good representation of what is being fed can be obtained. Send this sample to a reputable lab. With good silo management, the test results should show low bound nitrogen and soluble protein less than 60%. pH should also be measured. You can measure silage pH on the farm. Take a small sample and immerse it in water. Then by using a pH meter or pH paper, a reading of pH can be quickly obtained. Another measurement that should be tracked is temperature of the stack. Temperature should be below 90 degrees or less than 20 degrees above the outside ambient temperature. Remember, exposure to oxygen causes heating, so if the stack face is cool, this indicates good silage management. Bunker silos are increasingly being used in animal agriculture. But the use of bunkers to preserve feed requires attention to detail in harvesting, filling, feeding out, and monitoring the silage. The result? A reduction in farm expenses, better herd health, and more efficient production.